In the previous video, I just gone over the first question of the applications of differentiation. Now let's continue with question 2. A solid circular cylinder has a fixed volume of 1000 cubic centimeters. Show that the total surface area is related to the base radius x. So the radius is in terms of x by this equation. Now when you've got a cylinder, this is our cylinder here. If I get to open this cylinder, I cut it on the middle. So this thing, I cut it like from where we joined it, so it's going to be a much straight thing like that. And then we have got a circle on top and a circle down. So we wrapped this thing around, and that is what gave us a cylinder. Now we know that the distance around a circle, that is the circumference of a circle, is given by 2 pi r. So if this thing, from the distance from here to here, had to exactly fit around this circle like this, then the distance from here to here is also supposed to be 2 pi r. So this distance here is 2 pi r. Now this cylinder has got a certain height h, so this is the height which is going to be here, okay, like that. And how do we get now to find the total surface area? So this is a circle here, this is another circle here. We know the area of a circle. Area of a circle is given by pi r squared, but we have got two circles here, so the formula is going to become what? 2 pi r squared. Okay, that is going to be the formula. But remember, we are using the radius is not being represented by r but represented by x. Okay, so we're going to be using x in this case. So therefore the area is going to become 2 pi x squared, because we have got two circles. Now what will be the area of this curved thing? So the area of this one also is going to be area of a rectangle, just its length times breadth. So that is going to be just to be 2 pi ri, we are using x, and then multiply by h. Now because we want the total surface area, just get to add this and also this one. So let's go on and do that. So that is going to be total surface area is equal to 2 pi xh and then plus 2 pi x squared. Okay, so from the writing, I just forgot a square there. That is part of how it was given. Now after we do this, we can see that what we want to prove, there is no height there. But one thing that you've been given is that you've been given a volume, and volume of a cylinder is given by pi r squared h, and volume is 1000. So that is going to be pi r squared h, making h, of course x we are using it for r, so making h the subject of the formula, h is going to be 1000 divided by pi x squared. Okay, so we're going to now come here, area is going to be equal to 2 pi x, I don't know what I've written. Okay, that is an h, so that will be 2 pi x, but where there is h we are putting 1000 divided by pi x squared, and then plus 2 pi x squared. Now this x will cancel with 1x in the denominator because there are the two of them, and then pi will cancel with the pi. Therefore area is going to give us this 2 multiplied by the 1000 there, that is going to give us 2000. Remember, an x has remained in the denominator, plus 2 pi x squared, which you can as well write as area is equal to 2 pi x squared plus, okay, this is a 2000, 2 multiplied by 1000 divided by x. So this is what we can see given there, hence shown. Alright, now for the second one, given that x varies, show that a as a minimum at when x to the power 3 is equal to 500 over x. Now how do you show that? If the area is supposed to have a minimum, then we should be able to take the derivative of this. At the minimum point, we know that the derivative is supposed to be equal to 0. So I can as well take x on top. So this is going to be 2000 and then x to the power negative 1, like that. So here dA divide, divided by, so we're finding the derivative of a with respect, what is the variable we're talking about here? It's x. So it will be dA over dx, and that will be equal to 2 multiplied by 2. That is going to give us 4. Pi is a constant, so we don't need to worry about it. And then we reduce the power by 1. And then negative 1 multiplied by the function, that will be negative 2000. Reduce now negative 1 by 1, it will be negative 2. But because the power is negative, I can bring it down as positive. So dA over dx is going to be 0 if it's supposed to be a minimum or a maximum. That will be 4 pi x minus 2000 divided by x squared. Okay, from here now I can make this as a single fraction. So we're going to have 0 is equal to 4 pi x to the power 3 minus 2000 divided by x squared. If we cross multiply, what is in the denominator will go, so just remain with 4 pi x to the power 3 minus 2000 is equal to 0. Take 2000 the other side, so 4 pi is going to be equal to positive 2000. There's x to the power 3 here. So to remain with x to the power 3, I'm going to divide 2000 by 4 pi. And therefore, x to the power 3 is going to be, we know that 4 goes into 25 times, so that will be 5. And then 2 zeros will remain divided by pi. Hence, shown there. So, another one here, a cylinder can with a no lid as a circular base of radius r centimeters. Total surface area of the can is given as 300 pi centimeters squared. Show that the volume is given by that equation. Now for this one, we've been given as a can without a lid. So this place is just open. That means if we get to open up this thing, we cut it on the middle, all we are going to have is something like this. Okay, so this thing is like that. This point down is closed, but we don't have any lid there. So that means we only have a circle down here. And the area of a circle, we know it. That is pi r squared. And the distance from here to here is going to be equal to the circumference of the circle. And that is what? 2 pi r. And this is the height. That means the total surface area, which I can just say area, is going to be equal to the area of this. Simply multiply those two. That is going to be 2 pi r h, and then plus the area of this one circle. That is what? Pi r squared. Now we've been already told that the total surface area is 300 pi. So where there is total surface area, we're going to put 300 pi. So 300 pi is going to be equal to 2 pi rh plus pi r squared. Now you can see in this expression there is no height, so I'm going to make height the subject of the formula for my equation here. So this will be 2 pi rh is equal to 300 pi. I'll take this one the other side, so that will be minus pi r squared. Now because pi is common in everything which you have here, it will cancel out, and so we are going to have, I'll divide everything now by 2r. So we're going to have 300 minus r squared divided by 2r, like that. This is the height. Now we know that volume is given by pi r squared h. Therefore is going to be equal to pi r squared, where there is h, we are putting 300 minus r squared divided by 2r. And this is going to give us what? So just check what we want to leave it in the form. So 2 should be removed outside. So from here we can see that 1r is going to cancel with 1r, which is down there. So I'm going to remain with pi and an r. These two I'm going to bring it outside. So that is going to be over 2. And then inside we remain with 300 minus r squared. So hence shown. Now that we've shown, find the value of r for which v is maximum. Now we need to find the derivative of this one if we want to understand where the volume is maximum. So I can as well write this as v is equal to, I'll distribute 2 into 300, that is going to be what? 150. So that will be 150 pi r, and then minus this multiplied by this, that is going to be pi over 2, and then r cubed. Now we're finding dv over, what is a variable this side? Pi is not a variable, it's a constant, so it is r, so it is dv over dr. That is going to be 1 multiplied by 150, that will be 150 pi, and then the power of r is power 1. We reduce it by 1, it will be power 0. R power 0 is a 1, so it just be 150 pi, and then minus power 3 multiplied by the function, that will be 3 pi over 2, and then r now reduce it by 1, it becomes power 2. So dv over dr is supposed to be equal to 0. That will be equal to 150 as the maximum or the minimum point, 3 pi over 2 r squared. I'll take this term the other side, it becomes positive 3 pi over 2 r squared, and that is going to be equal to 150 pi. Okay, at this point now I'm going to multiply by the reciprocal of this so that I just remain with r squared, and that is 2 over 3 pi. So the 3 pi and the 3 pi will cancel, the 2 and the 2 there will cancel. So that will give us r squared being equal to 3 into 150. That should be a 50. And 50 multiplied by 2, that is going to be what? 100. So I'm not worrying about this pi because it will cancel with the pi which is down. That will give us r to be equal to positive or negative 10. But because this is measurements, we don't take length to be negative. So r is going to just be positive 10. That is going to be in centimeters. So that is going to be the answer to that one.